Hello, thanks for joining us today. The topic of this webinar is why axial flux motors are powering the hybrid shift, and it's brought to you by Turntide Technologies. There will be a Q&A session after the presentation, so please click the Q&A button on your screen at any time to submit questions. And a recorded video of the presentation will be available to view on demand after the session is complete. And we will send out a follow-up email later today with a link to watch the on-demand session. Our speakers today are Jason Glass, product lead, hybrid systems and EDUs, and Nathan Martinez, applications engineer at Turntide Technologies. Welcome.
Thank you very much. Appreciate it.
Very much.
What I'll do is I'll go ahead and we'll run through some introductions and then we'll jump right into the meat of the webinar today. My name is Jason Glass. Again, I'm the product head for Series Hybrid and or for hybridization and for our EDU technology. I'm a mechanical engineer. I've been in the industry and gearing, powertrain design and that sort of thing for about 25 years. Everything from overland conveyors to automotive. So super excited to run you guys through the webinar today.
Yeah, my name is Nathan Martinez, one of the applications engineers for North America here at Turntide Technologies. Based in Metro Detroit, so I came from one of the big three, so heavily automotive focused, mechanical engineering background, and have had a lot of experience in electrification, hybridization, and autonomous computing. So really excited to dive into our topic today.
Cool. So we'll kind of jump right in, guys, and get started and start looking at some of the things that I think Nathan and I and a lot of the folks at Turntide are super excited about, and the market shift that we're seeing. Excuse me, I'm going to cough a little bit today. Um, the market shifts that we're seeing in good grief. Hold on just one second. Of course, it has to start when you start a webinar, right? Um, what we're seeing is a shift in electrification and how hybridization is actually evolving, and the pendulum is starting to kind of move again. Where initially everyone was looking, okay, we're going to go straight BEV, we're going to go really hard at battery technology. And what we're starting to see now is that pendulum start to swing back into the hybridization of drivetrains for range extension, for power generation, for series and parallel hybrid drivetrains. And axial flux is really playing a huge part of that because of the topography and the design of the motor, and how these motors can be applied within a existing system, where you may have space constraints, you may have, you know, a design that can't be made different, like, the stringers in a boat, a drivetrain placement in a platform. So we're really starting to see a lot of changes in that. And one of the things, obviously, that makes that so easy for Turntide and for you guys as customers is the way that the axial flux is actually designed and how we're able to generate massive amounts of torque in a very, very small space. And we'll do a real quick overview of the axial flux motor itself and what makes an axial flux motor different from a radial flux motor is that we're applying that force along the axis of the motor instead of laterally down the shaft. So we're turning that motor over in an axial position. It gives us higher torque density, and it gives us a lot thinner body design. Um, and our motor is a little bit different than some on the market. A lot of the competitive motors out there, we all use a little bit of a different design, a little bit of different internals, where we use a single rotor dual stator setup. Our design allows for smaller or lighter rotational mass. We have, our stationary stators, which we manufacture in-house. Our rotor we manufacture in-house. The entire motor is really vertically integrated and allows us to really create a great package. And I'm gonna let Nathan kind of talk a little bit about it while I cough.
Yeah, so building off of that, you can see the number of magnets that we have within the rotor itself. This allows for a much lower cogging torque because you're not having as big of a disconnect in the poles as it's rotating or at that low speed kind of hand turning. You can also see the water jackets here. So on the far right, you can see the water jackets that are behind the faceplate on each side of the motor. So we've optimized the cooling channels for that as well to take out and dissipate as much of that heat and taking that out of the system so that the motors are moving at the most efficient system, part of the system. And you'll see that the numbers there in a little bit. But there's also a lot of customization as well when you actually get into the actual ordering of these units. The top box, for example, can be oriented in rotation of 90 degrees. The motor itself can be clocked when it's being actually mounted to whatever unit or device that you're using this with. So it can be clocked rotationally in any direction. And then also the coolant ports can be on either side of the motor as well. So we're really giving the customer customization in terms of how you integrate these units depending on the space constraints that we're facing.
Perfect. And as we look at the design of our motors, we're moving into our new version of the motor, our Gen 2 motor is what we call it. And it allows us to do a lot of really great things. And we've done things like take out weight of the housing to lighten up the design. We've changed a couple of the things, like now the motor comes standard as a hollow bore motor. So this means for our customers, we're able to adapt to any kind of powertrain, any type of setup that you guys may have existing or new. So through a plug-in shaft, whether it be, a spline drive, a key drive, a flange drive, we can adapt to that very quickly. We'll get into where we talk about diesel hybridization in a little bit, where we're plugging directly into the torsional coupler. So we're able to make an adapter shaft to drop between those two. So we've got a motor that's going to be about 4 times more power and 50% less weight. So more compact and more torque than your traditional large alternator style radial motors. Again, less rotational mass, which Nathan talked a little bit about that cogging torque. You get a really smooth performance if you're using it as a traction drive and a generator, really smooth performance at low speed. And then high efficiency at 96%. So again, this motor is only 110 millimeters thick in its largest size at 430 millimeter. So incredibly compact. And the other thing that we bring to hybridization is, and one of the things I think is a real turntide strength, that is that we have multiple motor sizes. We have 4 motor sizes, and we can stack our motors so that we can generate anywhere between 55 kilowatts and a full megawatt of power, depending on the arrangement of the motors. And that's something that's pretty rare within the industry right now, to have a fully commercialized range of motors from 250 millimeter motor all the way up to a 430 millimeter motor. Our smaller motors are, you're going to be in that, higher speed, 8,000, 12,000 RPM, and then up into larger motor sizes, you're going to see the 3,700 to 4,000 RPM, but massive, massive amounts of torque, which is really what we need for power generation. So this nimble design allows us to have everything from an SAE1 flange design all the way to the SAE5. And this design allows us to adapt to any size motor. So basically anything from, say, a 1.5 liter all the way up to a 12 liter, and we're working on a 15 liter design as well. So we're able to adapt to what you need to produce in the package that you're able to or that you have available to you. We're also working on, these flanges are all designed around the SAE. So we can adapt to each of those, help you guys select the right size, help you select a torsional coupler that's needed between the motor. And we do that to handle torque ripple and vibration and that sort of thing. And again, with that female bore on the motor, we're able to adapt to any type of drivetrain. The other one is where we can actually adapt to your transmission or a gearbox or a transfer case. So in the instance where you're looking at, say, a drivetrain that is motor gearbox, a lot of our marine applications are that way. We can slip in between that motor and your gearbox or that motor in a transfer case to give you an alternate power source or a place for power generation. Nathan?
Yeah, absolutely. And then further along that, we have multiple turn counts available within these units, each of our models. So anywhere from 2 to 6 turns directly correlates to the amount of current throughput that you're pushing through the units, as well as the amount of torque that comes out, and then therefore also the efficiency. So depending on your use case, your operating point, your duty cycle, we can really narrow down and make sure that we're getting you the most amount of power output for the least amount of electrical power usage that you're looking for.
Great. And the other thing that we were looking at too that's started to become part of the conversations, and I see it a lot from my customers and the folks that we're talking to are what is the total cost of ownership of the platform and how can we improve that and increase that? And this is really a big thing coming from the automotive industry where Nathan and I kind of lived our lives before is not just total cost of ownership, but what is the serviceability of the system for your customer? We see it a lot where, there's some great systems out there where they're fully integrated. They've got 5, 6, 7, 8 components all blended into one, but what's the serviceability of that? And we really want to know, what your system looks like and how can we help you improve your total cost of ownership and decrease that. So we're looking at improving your vehicle's range as a range extender functionality. Um, we can also do traction drives. We can do power takeoffs, which is becoming a huge part of the industry as well.
Mhm.
We also have improved reliability. So what we're seeing, and when we talk about improved reliability, is really getting your ICE or your diesel engine right at that optimal running performance point. As you all know, there is a premium point when a motor reaches the optimal temperature, optimal RPM, and optimal torque. And that means your motor is going to last longer, to decrease the number of oil changes you may have to do. If it's in let's say, a last mile application, you're using regenerative braking instead of wearing out the brake pads ahead of schedule. If you're doing, say, a middle mile box truck where you're using general labor or you've got drivers that are maybe not as skilled as other drivers, where they're heavy on the brake, heavy on accelerator, we're able to monitor that and help you guys, kind of target that as, hey, how do we get the optimal performance out of every single platform that you may be working to develop? The other one is your engine's going to last longer because it's in that optimal heat. Your oil's going to stay exactly the way it's supposed to be. Viscosity is not going to change. You're not going to burn off the additives. So we're really going to help you guys decrease your total cost of ownership. So the other part of this, as we start to get into it, is we're scalable from day one. And this is really where I start to get excited. So I kind of have to remember to slow down and talk a little bit slower. Um, it's really exciting when you get into the performance economics of how axial flux technology can really be added to a diesel drivetrain for increased performance. Because our motor is lighter, a lot of times the portions of the drivetrain we may be removing, we actually overcome in weight. We've seen applications where we have a customer that's using a 6.7 liter diesel or a 6 liter diesel. They're able to drop from that 6 liter down to a 4 liter. So now you've got a lighter truck, you have a lighter drivetrain. You can use a smaller battery package because we're generating power on demand. So there's a lot of really exciting things as we get into the architecture that you guys have in your platforms. We have multiple different designs too, and that's really the exciting part of where the industry is. We're seeing drop boxes being used. We're seeing inline gear units that we offer to customers. We have transfer case applications for traction drive and for power generation. So there's a lot of different things that you guys can do and that we can help you guys develop as you look at hybridizing a system. Whether it's two-wheel drive, four-wheel drive, there's a lot of really awesome options out there right now to help you guys really develop some exciting things and kind of expand where you think you might be able to go to where we can go. And I'll let Nathan kind of chime in here, but we have some really awesome opportunities coming down the pipe with some OEMs and with some aftermarket retrofitters where we're removing the transmission and adding in a series drive. So Nathan, I'll chat a little bit.
Yeah, I think one of the most exciting and realizations that I've come to is that the accessibility to hybridization and new futuristic powertrains is no longer in the hands of just the OEMs. It's now becoming widely available to everyday companies that want to push the envelope in their respective industries. So we're talking drivetrain, we're talking generator and generation use cases, auxiliary functions in the power takeoff side that Jason was talking about. So there's a lot of other areas that these products fit and that we can really optimize for that haven't been looked at in 50, 60 years. For example, we're working with a company doing oil rigs, and they always laugh that, yeah, oil rigging is, 50, 60 years behind the latest breaking cutting technology. And so looking at something like this, it's drag and drop, it's seamlessly integrated, and the setup and controls really are accessible and usable by an everyday company. People that have, electrical engineers will be able to pick this up and start moving very easily with it.
Yeah, Nathan hit on perfectly. You know, a lot of times when you're looking at trying to figure out how to hybridize a system, it gets really complicated because you've got to add so many different things. And what Turntide has really taken on is how do we make hybridization as easy and simple for you as a customer from the get-go? Something that is compact, lightweight, that allows you to not have to make massive changes to an existing drivetrain in order to hybridize it. One of the customers that we worked with when it comes to, you know, adding that axial flux in, all they have to do is take out 115 millimeters of drive line, and their existing drivetrain doesn't change from the bell housing adapter on the motor forward. We're simply adding in between the transmission and the transfer case an axial flux motor or in between the transmission and the motor. So there's a lot of different ways that we can apply this and make it super simple for you guys, as you start to look at how do we hybridize a system. And, you've got a lot of different things that make our motors, very, very unique. One of the other things that's very unique about the way that our system functions is we don't try and cram everything into one big unit. And this allows you guys to be able to make a very rapid prototype without having to try and figure out how to put a gigantic drivetrain together. Being that they can be dropped in line, it kind of helps with a lot of the things that you guys see on a day-to-day basis when you're trying to design a system by remote mounting the motor, remote mounting the inverter, especially when it comes to retrofits, you've got to have a lot of different places to put things.
Mhm.
So we really have a very compact design that's going to allow you guys to do that. Kind of getting into some of where axial flux is really going to make a difference for you guys is as you start to look at how do we maybe retrofit a fleet, how do we retrofit our existing platform? There's a lot of different ways that we get there. Performance gains is obviously one of the top things that everybody looks at. How do we get more performance out of our current drivetrain? How do we not disrupt the systems that are in the car? And how do we how do we accomplish those things all at the same time? And one of the things that we've seen is there are times when you may need to be ICE, you may need to be BEV, you may need to be REV. And everything is kind of shifting into different ways to do that. And we've really worked hard to come up with a system that's going to allow you guys to see those things, your reduction in total cost of ownership, reduction in fuel consumption, tailpipe emissions, noise reduction, but also improving uptime. We have several different customers that are removing the transmission in their last mile and middle mile vehicles because that transmission is getting worn out from stop, start, stop, start, stop, start, which is really where we see the hybridization coming in strong in those two industries. And then also giving you the ability to potentially downsize that prime mover or your larger motor. And one of the ways that we do that, and this is kind of a roughed out sketch, this really isn't an accurate representation, but it's here to kind of explain to you guys. One of the things that we're coming up with is a multi-flex hybrid drive system. And this allows you to maximize your drivetrain and maximize your ability to be flexible by giving you all four drive modes or all three drive modes in the same package. And one of the common questions that we get a lot when we look at the multi-flex hybrid drivetrain is what happens when one of these motors isn't turning? And our motor is capable of what we call freewheeling. So we can demand zero torque, and the motor doesn't produce a lot of power. And Nathan can kind of jump in and talk about how little that is. But our inverter is able to manage that. So there's a lot of systems out there right now where that motor can't freewheel without generating power. Our motor is unique in that. But with the multiflex, we're able to combine a drivetrain together with your existing platform that allows you to choose, manipulate, or design a system that functions multiple different modes in different driving conditions. Go ahead, Nathan.
Yeah, absolutely. So with our control system itself and within the internal capacitance within our axial flux motors and our inverters, we're able to capture some of or withstand some of that generated power when in that free spinning state. And then conversely, when we actually want to build up uh, power and put that back into a system, put that back into an energy storage system or capacitors in some way or somehow we're able to do so on demand. And so the control side is really, really intriguing. Obviously, as an engineer, that's the biggest piece for me as well. But on a practicality standpoint, it's something that gives us a leg up on a lot of other systems where we can really tailor and tune that system to operate exactly how you want when you want. So whether you're driving in traction or you're generating or you're trying to do both, you were able to do so with our control side. And then I just wanted to talk on the TCO thing a bit more. I don't think we should minimize some of the things that we talked about in terms of noise. Noise in a construction site is obviously extremely distracting for everyone around. We've seen electric and hybrid electric construction and machinery equipment that traditionally would be making a huge ruckus, and we've seen that next to residential homes, schools, restaurants, and all of them with electric and hybrid systems have been able to still enjoy and move and operate their daily tasks without that disruption. So it's really, really huge on that front. Additionally, we've seen from my previous life in last mile delivery of full electrification, infrastructure was not present at the time and still being built up. So having the ability to self-generate power within your own vehicle subsystem is huge. It doesn't leave you reliant on going to a Tesla charger that has a 30-person wait line. You're able to generate your own power, put that back in the system, and continue to operate as you intend. Additionally, like Jason was talking about, the just less moving parts means that you're going to have less mechanical failures and less maintenance needed. On top of that, also scaling down the size of your engine if you so please, for whatever use case that you're using it for, saves you upfront cost, space savings, weight savings. You may even be able to reduce down to a smaller class truck, which may give you other tax benefits as well. We were talking about how small and lightweight these units are. We're talking anywhere from 29 kilograms up to 105 kilograms. So for our North American counterparts, we're talking about 65 pounds up to 220 pounds of overall weight compared to what you'd find in an engine that's 400 to 500 pounds plus. So huge reduction there. Um, and so it really opens a lot of doors, and the TCO that you'll see is significantly quicker than a full electric vehicle. And then I guess the kind of the final piece is you're able to have that familiarity with the systems that you're using today. So what we found in the past was that a lot of companies, OEMs, large distributors, sometimes have fear of accepting a totally new, totally bespoke design of a system or of a vehicle or of a car that really disrupts and is really capable, but doesn't necessarily give the end user the confidence in this new technology. So I'm talking like the drivers, the technicians, the people actually hands-on with the units. If they're able to still use and see the same form factor of the box truck that they've been working on for 20 years, and still know all of the HVAC and other internals that don't touch this system, that just gives them a lot more confidence and acceptance in terms of migrating towards this technology that is, albeit still being rolled out in a lot of different industries because of multiple different reasons. So yeah, that was what I wanted to touch on as well.
Yeah, so we've in the mid mile, last mile, and even delivery trucks and performance alike. One of the things that we've seen a lot of is a push to go to series drivetrains, whether it's combined together like you see here in the multiflex, or if you've got a segregated drivetrain. We've seen a lot in Marine, we've seen a lot in Department of Defense, military applications and platforms where you've got a power generation system and then you've got a completely separate electric drivetrain. And really what this system is designed for is that series drivetrain or a parallel drivetrain where we're adding boost to the drivetrain. So what this allows us to do is to switch from a completely ICE drivetrain to a series drivetrain to an electric boost drivetrain to a battery system to a rev system. So it's really allows you guys to have any of those options, or what's really cool is you can have all those options in the same package, which is, we think is really going to be transformative to the way the market shifts. And it's really ideal because what we see a lot of times, and you guys, if you're dealing with heavy trucks or your class 4 or 5, box trucks where you're using a 6 7 diesel and a transmission, you've got a fleet of these maybe. Your drivers, when they take off from a stop sign, we all have seen it. They take off, big puff of smoke because they're trying to drive it like a NASCAR. Or if you're in Europe at an Indy car, they're trying to take off like an F1 car, and your gas mileage goes through the floor. The performance of the truck goes down. Your motor's not running in optimal speed, and they're just overworking the chassis. And what this allows you to do is to take that motor, generate power, use the electric drive to give smooth performance, to give that driver less control perhaps over how fast they accelerate, keeps cargo from shifting and all kinds of things. But we also see that you're using that electric motor that is designed to generate massive amounts of low end torque at low RPM to get that truck moving in every single one of those stops. So we're seeing massive increases in diesel efficiency and fuel efficiency, anywhere between 25 and 30%. So, again, regenerative braking in a truck of that size, you have huge amounts of regenerative power that we can capture in the battery pack. And then you're just reusing that. And the really nice thing is one of the really cool applications, and I'll try not to get off in the weeds on this, is we're starting to see geofencing where diesels are not allowed to idle inside of a certain you know, city limits, say.
Mhm.
So this system is also capable of geofencing. So when it crosses a border, the diesel effectively shuts off and you're running on pure BEV until the batteries need to recharge. So you're able to have these multiple driving functions and generate huge amounts of power in a drivetrain that's basically the same length as a transmission today. So really exciting to kind of look at that because even when you go to full BEV mode and that diesel's off, right? One of the really cool questions is how do you keep all the AC running and all the other stuff running on the truck? There's a really cool system out there that allows us to do that, keep all of the accessories running using 48 volt power. It's a really cool design, and we're super excited about that. But this really allows you guys to have multiple different ways to do it, and being glycol cooled, right? We're able to maximize keeping that motor cool without affecting the way the diesel's running. So we're not trying to pull oil together, make one big gigantic system out of it. It runs on its own system, it cools itself. That way, again, that ice is kept in that perfect position. And we can pretty much handle any diesel down to, I think the smallest diesel we would probably want to work with is the 3/4 of a liter to a full 1 liter motor would be the smallest size with our 250 millimeter motor. But it really depends on kilowatt production. We have some customers that want, hey, we just need 10 to 15 kilowatts to keep our 12 volt system charged or to keep accessories running when we're at idle or something like that where they need little tiny bits of power. And then we have other ones that are like, hey, we need to make a megawatt and a half to keep our systems running at hotel load or whatever that platform might look like. So there's a lot of different options. But then you also, with this system, have the ability to run full ICE transmission. So you can use the ice in over the road towing or over the road performance because we know at higher speeds and pulling heavy loads, diesels are really efficient when you get them into that prime position. It's just hard to get them there and get any kind of fuel efficiency out of them. So we're still able to do that, charge the batteries, even add a little bit of energy to that drivetrain, allowing for better efficiency and decreased TCO.
And conversely, with our electric motors, they are almost the opposite of what you'd see with ICE engines and diesel engines, where immediate torque availability at very low RPMs, all the way through up until a term what we call field weakening. But um, you're really getting the opposite, and you're really able to attach these onto the systems and add that boost, add that torque smoothing, and that's where a lot of the secret sauces when it comes to turntide. It's how we have capabilities to be able to smooth out your ramp rates, prevent clunking within the system, which adds mechanical fatigue on your mounting points and on the internal gears. So we're helping reduce the chipping of teeth on some of those gear sets. As well as the overall feedback loop between the vehicle control unit, the transmission control unit, the engine control unit, as well as the motor inverter as well. So a lot of that tuning is where our applications engineers and design team have a lot of fun because that's where we're really customizing the solution to your needs and to your use case.
Yeah. And one of the really awesome things about the way that Turntide goes to market is we are not product specific. And we what we try to do is not be a product provider, but be a partner.
Mhm.
So that's a huge part of what you guys struggle with. And I think, a lot of times what we see is, hey, we can get this, but there's very little support for it. Or, how do we design this system? That's what Turntide does. That's what we're really working hard to be, especially with Nathan and myself and a couple of the other application engineers. We really work on understanding the application. And that's really where this drivetrain kind of came from is what are our customers asking for and how do we create something that isn't so complex that they can't work on it? And being kind of vertically integrated with the motor, we also manufacture our inverter. And we have the software to control the inverter. So it makes it really easy for you guys to come up with a system that's designed for what you guys are looking, to design, implement, or prototype. So what we'll do is we'll kind of run through a couple of different applications where we've seen huge success. Nathan and I'll both kind of chip in on both all of these, and then we'll get to your questions. But CMD Marine is one of our customers. right now we're seeing huge pushes in diesel hybridization in the marine industry, where normally the alternators or the DC generators or the generators that you use in a marine application are as big as the diesel itself. We're able to take that design and really make it compact. And for some of you, what would you do with 240 kilowatts of power that came in 250 millimeters of axial length? It's a huge amount of power in a very, very compact space. Because as our power grows, we grow radially, or actually, excuse me, we grow in dimension and not length. So we can get bigger in dimension and generate massive amounts of power. And that power can come as low as a couple hundred RPM. All the way up to, smaller motors, 8,000, 9,000 RPM. Our biggest motor, 430 millimeter, is 3,750 RPM. So really, we have that range in dimension and that range in speed, that allows you guys to be able to generate huge amounts of power in very, very small spaces. Um, Again, commercial vehicle electrification, being able to place a drivetrain or put a solution together for you guys that's based on the size of the platform that you have. So everything from, your little small delivery pickup trucks to your small, almost your NEV type, last mile delivery vehicles, all the way up to that 4, 5, 6, 7, and now even Class 8 trucks. Being able to provide an electric drivetrain that can generate enough power to move that truck. So really trying to find the best solution for you guys, in your application. And finally, we'll kind of touch on this one. Nathan and I bring up box trucks a lot, just because we're both kind of passionate about figuring out a solution for this thing. And kind of seeing this and developing and building the prototypes that we're involved in now is it's such a perfect platform for hybridization because it's already built kind of around it with the design in mind. Go ahead, Nathan.
Yeah, so there's multiple areas that we can drag and drop some of our units within these. We mentioned before, obviously the traction drive is the huge one. Being able to mount exactly in between the chassis rails makes it a huge advantage. We've seen customers want to entirely remove the engine and just have the motor and the transmission. And we've also seen where we do more of a hybridization approach where we're having the engine, the motor, and then the transmission as well. With the design that we have, and how we intend and how they're supposed to be mounted, obviously able to take a lot of vibration. With the dual coolant jackets on either side, we're able to maintain the temperature that we're operating in. And we're also able to have a lot of our power electronics that are maybe even on the low voltage side. So think about the auxiliary systems like your HVAC, like your boom lift to raise and lower the box on your bed, for operating power takeoff for other auxiliary systems like charging power tools or running welders, running anything that's in that low to medium voltage, is something that we can absolutely take on. And like Jason said, we love to do this kind of stuff. We love to see what the challenges are, and really lay out the different proposals in terms of what different pieces can we pull on and with our partners as well. How can we leverage their products, their expertise, their speed of delivery, to get you an early prototype. And more times than not, we've seen that we've been exceeding customer expectations in terms of how these products have been seamlessly integrated, how they've been meeting and exceeding performance metrics, and really just executing on a really high level.
Yeah. And I think the other, kind of bounce off what Nathan said there too, is we're seeing a huge drive toward the EPTO market, especially here in the US where we've got, platforms where they're taking a 4,500 or 450, level truck and they're adding a bunch of equipment to it. And now your hotel load goes through the roof because you're trying to run welders and generators and AC compressors and air compressors and all these different, products off of that main drivetrain where we can pick up and generate power in that situation. We're also seeing it in where you're trying to generate power for maybe a reefer truck as well. And then a lot of it in the marine side too, where at lower speeds, a normal alternator can't generate enough power to compensate for higher hotel loads from electronics, from different systems that you may put on the platform. So we're really seeing that as a driving force behind, how do we help hybridize systems and make them really, really, easy to prototype, easy to service, and easy for you guys to implement. So what we'll do is we'll take some time and kind of go through the questions there. If Lori, if you want to kind of sort through those, and we'll kind of just try to answer those questions as fast as we can, and gives us about 20 minutes or so to answer questions, which is typically where I get in the weeds. So
Great. Thanks so much for the presentation. Thanks everyone for submitting questions. We have quite a few that have come in so far. So if you have any more, please use the Q&A button to submit them. And I'll start right here at the top and read them to you guys, and you can give us your feedback. So the first one I see here is about loss of performance because of magnet at high rotational speed. Is it different than radial flux or the same problem?
It is the same problem. Mathematically, it is, yeah, the same problem. So we're seeing that um, when you get to basically the knee is what we call it, where you'll have a relatively constant allowable torque, and then that starts to drop off significantly once you reach field weakening. And so that's when you start to fight the back EMF of the system itself and of the battery and of the generated back EMF voltage of the motor. So you do have to do some mathematical changes in terms of how much current you're injecting, where you're injecting that current, and the amount of torque that is available. So similar, but albeit there's a big difference in the sense that the performance of an axial flux motor is usually significantly higher for the form factor that you're comparing it to. So radial flux may be probably anywhere from 2 to 4 times as long in length compared to an axial flux motor, and normally about that much as heavy as well, just to achieve the same performance.
Okay, great. Another question here. Can you repeat the optimum RPM of this motor?
Yeah, so for our different motor lines, Jason mentioned that we have varying top speeds of the different motors. So the smaller in diameter that the motor is, the higher the RPM available with our specific motor line. So our smallest motors will be 8,000 RPM available. The next size up, which is the 400 millimeter motor, has 5,000 RPM available. And then the largest motor that we offer in terms of diameter is the AF430, which is 430 millimeters in diameter, and that has a top speed of 3750 RPM.
Okay.
And so when you stack those, so if you get a double stack, triple stack, quad stack, your available RPM does not change in terms of the speed that it's able to rotate at.
Okay, great. Here's a question about diagnostic ability and information you provide the end user technicians who work with. I find a lack thereof to be a huge barrier for my clients in the aftermarket hybrid electric systems. Yeah, so can you talk a bit about diagnostics systems?
yeah, I think from a customer service side of it and engineering support side of it, that's a huge part of what Nathan and I, and Nathan being on the application engineering team, we have an entire team dedicated to customer support and making sure that not only before you build that we're part of the program, that as you're building, as you're designing, and then after support, those same engineers stay on to continue to train your folks. So we're very, very involved from a customer support, customer satisfaction side, and making sure that you're able to do that. We actually write our own technical manuals when it comes to a specific custom application. I know Nathan's been involved in a couple of those where we've had to, basically write a user's manual just for a specific customer, to make sure that they understood exactly what's going on. And then I'll let Nathan kind of dive into kind of the diagnostic ability of the software.
Yep. So we do have UDS commands. We're able to provide trouble codes, diagnostic trouble codes over the CAN network. We our inverters traditionally use CAN or J1939 to communicate within the vehicle or system that you're working within. So you will be able to know live what's going on in terms of what's faulted, what's failed, what's been over the allowable threshold or limit, and be able to work back from there. And we also have a trouble code list that we share with you for our inverters that know what's going on with the motor and with the inverter that it's being used with. So that should give you enough to triage and work your way into understanding what's happening. And then obviously, like Jason mentioned, that extra layer of being able to reach out to myself or to another Turntide applications engineer to help uh, root cause analysis for you if it's something that's more system or holistic. Because normally we find that it's actually there's something outside of the system that may be interrupting communications or adding additional faults that weren't necessarily considered during at the initial design of the system. And we're able to help you backtrack that and understand why and when and where that issue may occur.
Okay, great. Two kind of related questions here. Is this a PM motor? And how do you manage back EMF that Nathan mentioned? And another question is what kind of permanent magnets do you use?
So it is a PM motor. It's a PMAC permanent magnet AC motor. And how do we manage the back EMF? So that's managed in our inverter. So we have kind of two operating modes. We have geometric and lookup tables. For those that are kind of in the industry, you're probably familiar with them. But with the geometric mode, we're calculating and using a feedback loop, obviously from the sensors within the motor and in the inverter of what's going on from an electrical standpoint, your current, your voltage, and then managing it that way through math. And then the lookup tables have actually uh, validated and tested operating points along the entire operation band. And so we know at this specific operating point, we need to have this much current, this much voltage, this is the torque that comes out of it and the speed. And so we know specifically it's physically mapped within that unit. And so that's how we manage it there. And so would love to kind of go into details with you. If you reach out offline, we can talk about your specific operating point, if it would be within the field weakening area of our motors, then we can obviously work through that application specifically as well.
Okay, here's a question about development. How are you testing control software in the inverter and motor power electronics before you're installing the product? Are you using HIL hardware in loop? Thank you.
Yeah, so we have a very large testing capabilities at our facilities in Gateshead. We have multiple dynos that we do put our the specific motor and inverter combination that you've ordered or purchased onto the dyno, and we will do either that geometric pairing that I talked about, which is mathematical based, or the lookup table, which is the testing and feedback loop at certain operating points or all operating points for that matter within your voltage range. So we do a bit of both on top of the early system scoping where I'm using actual motor performance data to understand how it would perform in your use case based on the duty cycle that you provided me, and based on some of those operating conditions as well. We backtrack that. That's how we make our recommendation. And then, like I mentioned, we then take that to the dyno and test that accordingly. Now, if you have if you have a partner product, we work with them to help get those tables generated. We also have other resources to do a lot of dyno work as well if there's something more specific or bespoke that you're looking to have done.
Okay, great. And then let's see here. We have some questions about drivetrain configuration. In multi-flex hybrid configuration, do you still get the possibility of direct mechanical drive from ICE to drive shaft at highway speed? Or is it always through the generator traction motor power electronics flow? And from the also from the audience member Renee, what is your system rated operating voltage?
Yeah, so the in the system itself, you do have the capability of driving mechanical power directly through the system. Now, whether our motors are demanding torque or not, that's kind of up to your design, your needs, system requirements or not. Um, prime example of this is we're working with a customer right now, and they're using this exact system, and they didn't need a ton of power. So we actually looked at the amount of torque that we were transmitting out of a 7 liter diesel, and we sized the internal spline drive to match that. So we actually went from a 400 millimeter motor to a 430 millimeter motor. And that allowed us to transmit more torque directly through our motor, even when our motor isn't requesting any torque at all. It allows us to still be able to transmit that torque safely through the drivetrain. The really cool thing about Turntide too, and I kind of saw another question kind of asking about material, is we have engineers on staff who that's their whole job is to look at the materials, to look at how we're applying torque, how we're designing mechanical systems to make sure that we're not overstressing the system, to look at the grade of steel that we're using, to look at the heat treat process, and make sure that we're designing a system that's going to be up to par with you guys. We can also simulate a lot of that data through several different pieces of software that we have and that partners have that allow us to look at real world application and simulated data. I think that was a later question that came up too. Is you look at your virtual twinning system or digital simulation. We're able to do that through a lot of different software. You have map software, you've got ADAMs, you've got a couple of different pieces of software that allow us to take our designs, put it into that virtual world and see how that drivetrain moves. Um, I'm working on a project as well that, we're taking an entire chassis with suspension, with driveline, with everything in it, and looking at how that drivetrain is moving, how that torque is being applied, and what are the results of that to the chassis, to the frame, to the motor itself, to the bell housing adapter, all the way through the entire system. So we really do focus on making sure we're not just saying, hey, here's a old motor out of you know, a Volt or something like that. We're just going to slap it in your car and really hope it works. We spend a lot of time looking at the design of these systems to make sure that we're partnering with you guys in creating the most reliable system that we can.
And then just to tail onto that, the rated system voltage is up to 800 volts DC. We've seen it work as low as around 200. But when you get in that lower voltage range, then we really have to look at how much current you need to meet the power requirements that you're operating at. So
Yeah.
it may or may not be recommended, but we always look at that, obviously.
Great. Next question here. Can you please explain how this type of motor outperforms conventional radial flux IPM SMs in regenerative braking, particularly at low speeds?
I think the kind of first and main thing that comes to mind is if we're comparing, apples to apples, then we'd want to look at the form factor. If you're comparing a radial flux motor of the same size, let's say weight and dimensions as our axial flux motor, we're going to be able to produce significantly more regenerative braking energy because of the amount of torque that we're able to accept into that motor. If you're going to have a radial flux motor of the same dimensions, you're just not going to be able to take that much torque because of they're not high power density. They may be as efficient. They may be able to operate at the same RPMs. But the torque density just isn't nearly as met for the size that you're getting. So, in that situation of regenerative braking, your brake pads are going to have to actually apply force to slow that vehicle down, and you're not generating as much power compared to with an axial flux. You may not need to use the braking pads until you're actually coming to a complete stop, and the regenerative force that the axial flux motor is putting onto that rotating mass is going to be all absorbed and taken into the battery.
Great. Next question here. Is your inverter hardware and software engineered to ISO 26262 functional safety?
That is a great question. They are. So our latest generation of inverters are the Gen 6, And the size 9 is specifically the one that we have used with our axial flux motors. And so that unit itself is ISO 26262, and they're ASIL C rated. There are some, if there's obviously an opportunity, we'd love to talk about if they need to be ASIL D, or if, they can even be QM rated. But yes, they do meet the ISO standard that was mentioned there.
Excellent. Can you talk more about 48-volt systems for accessories?
Well, that's something I can, if you want to connect with me, Jason, on, shoot me an email and I can connect outside. It'd take me a little while to go through that. I kind of like to get through the questions. But yeah, we can definitely, if you shoot me an email, I think my email's up there. But yeah, if you shoot me an email, we can have a long conversation on that. Sorry.
But yeah, it could be anything from hotel loads to everything that we're doing at high voltage, but at a lower voltage as well.
Yeah.
Great. All right. Let's see here. You mentioned glycol to cool it down, and that it's cools by its own. Can you explain how this is done? Do we have to
Yeah,
add
so
more
we
lines? Sorry.
Yeah, sure. Yeah, that's what. So the doesn't do it on its own, but so our system is kind of a standalone system. So we have our own thermal management system. So it would be added to kind of its own system. Not what we try not to do is integrate our cooling system into another cooling system. We stand that off by itself. We do have our own 48 volt pump. We have our own 48 volt fan, or 24 volt as well. But it allows us to kind of separate our system from, say, an existing cooling system. So we're not forcing a customer to alter a chassis design or something like that. We just add to that system instead of requiring you to come up with a way to integrate it into a current cooling system. We just add to instead of adding load to a current thermal system.
Conversely, for the inverter and motor, those can be on the same coolant loop,
Right.
since they both are water ethylene glycol cooled. So you're able to, knock out two birds with one stone, if you will, cooling both your inverter and the motor on the same system and not needing independent dedicated systems for each of those components as well.
Great. Let's see here. I see you are still using spline shaft for torque transfer. How can you guarantee the quality over lifetime due to massive torque peaks from ice, in particular with diesel engine?
Yeah, so we do a couple different things. First, it's about the way that the spine is designed. The other thing that we do, which it's kind of an interesting part of the market. I have customers who don't use, and I have customers who do use torsional couplers. And one of the things that we push really hard for is using the appropriate design and size torsional coupler. Um, and as you guys know, when a diesel fires, it generates a massive amount of torque right as it fires. And that torsion can actually weaken the shaft over time. So we always use a torsional coupler between a diesel motor and our electric motor, to take up a lot of that momentary torque that we see the shaft take. That helps alleviate and lengthen the life of the spline of the interconnecting shafts. Helps to kind of isolate too, so that you've got those torque ripple effects and that sort of thing that come from huge torque spikes. So that's really how we manage that. And then it's also about how do we design the system and size the ID of that shaft appropriately. That design and that ID tells us how big that motor needs to be in order for us to be able to compensate for that torque transmission.
Great. Another question here. Does Turntide have motors that can operate in vertical shaft orientation?
Yeah, all of our axial flux motors can be laid flat and operated vertically.
Great. Another one here about eVTOLs. Is axial flux motor applicable in eVTOLs?
Say that again. Sorry, I got to find that one.
Sorry, is axial flux motor applicable to electric vertical takeoff and landing? Uh,
So and Nathan, you can jump in on this one too. We're testing some with customers now. So eVTOLs are kind of one of those ones that get into how much space do you have to cool? Is it air cooled or liquid cooled? And can you hit the right RPM? Um, right now, we currently don't have an air cooled version of the axial flux motor. We know we can cool it with as an air-cooled version. Performance is obviously affected by temperature of the motor, so that's one of the things that we definitely would have to look at with a customer. But we definitely have eVTOLs on our radar as an application, especially for our AF 125, which is our 125 millimeter motor. That motor is capable of really, really high RPM. And that motor's kind of perfect for that application, like a heavy lift eVTOL. Which gets into, I saw another question that was, what's a critical component where quality is the most important? And we manufacture every single part of our motor. So really kind of the center in that rotor and the way that rotor is manufactured and designed is one of the most critical things that we do. Second to making the windings and forming the stator. And our motors, it's very interesting being a car guy and kind of being a racer and some of the things that I do. I'm always looking for how far can I push our product. And that always comes down to how well you can manufacture that stator and that rotor, primarily the rotor that's got to be spinning at, 4 or 5 thousand RPM, 6,000, 8,000 RPM, keeping that rotor together. And that's always where we look at the materials that we use, the design that we use in the application to make sure that we're selecting the right motor for your application every single time.
Mhm. And then
Great.
just one more consideration on that
Sure.
is the FAA requirements, obviously, for anything that's going to be in the air. So,
Yeah.
love to talk more about that and some of the regulations there.
Great. Here's a question about the motors being used as generators for on-site power generation for applications like data centers.
Yeah, I could take that one. So using the motor as a generator is a very, very applicable use case. Obviously, we're running at a pretty optimal RPM range for that. Um, Diesels run, traditionally less than 4,000 RPM, and our unit, our biggest unit that is able to accept the most amount of torque and produce the most amount of power, operates at that 3,750 RPM that I talked about. Um, so this is a really great one for generating a lot of power in a very small size. We have some partner companies and customers that we're working with now to do power generation on site. If you look into Jason and I's race day at King of Hammers, you'll see we even use generators to charge our EVs. So a huge application for us, and really a big unlock there. And then obviously for data centers, that is a huge industry that's blowing up now, as everyone knows, with the latest AI technology coming out. So the need to cool these these data centers is paramount. Um, Traditional HVAC systems have not been meeting the needs, and the ever-changing landscape of the chip market and how chips are produced and how they operate is also ever-changing. And so we know that for our motors, they spool up extremely quickly, and you get torque immediately. So you're reducing your bring up time and your coolant time for that fan system or even that coolant system itself, from minutes to seconds, if not even fractions of a second. So it's a huge unlock for us, and we're really excited to get our products in more of the data centers with some of the companies we've been talking with.
Yeah, and I think the really nice thing about using our motor as a starter for a diesel is we can go to full torque, full power in a moment, setting that up. So a lot of times what happens with a diesel generator is you've got to spool that generator up. get the diesel up to temperature, getting up to power, not damaging the diesel, when it comes on at full load, full power right away. With our axial flux motor, using it as a starter, we can bring that diesel up to speed really, really quickly, which allows you to be able to generate power immediately, and prevent any loss of service. So, it can be utilized in both applications where we're generating power instantaneously, but it can also bring that generator up to speed really, really quickly. So it's kind of perfect for that application.
Great. So we have time for about one or two more questions here. So we have one here from someone who joined late, and he said, "Can you please let me know what the temperature ranges are of the motors?"
As far as
Yeah.
performance wise, or I guess it'd be a little bit of clarification. Excuse me.
I would assume performance. We can operate down to -20 and up to, Jason, keep me honest here, I think 70 degrees C.
Yeah.
But we're actively looking at how to unlock on the colder end of that range of that spectrum and bringing it down to potentially even -30, -40. As we know, there's a lot of different types of equipment that operate in that zone. So it's not that we don't meet those requirements. It's actually just getting certified to be able to say that we can operate at those requirements.
Yeah, and you'll see some things where we've one of the customers we work with is looking at a very, very specific temperature range to be able to operate in. And, you know, their batteries can't operate in the temperatures that they're trying to figure out how to get our motor to operate in. So, but when you're looking at power generation, especially if, I'll just kind of spitball something here, but say you're looking at an Arctic research facility that deals with extreme, extreme cold weather. That's really getting into, the materials that we use on the inside, the housing material, and the bearing itself.
Mhm.
There are several different companies that make some really amazing cold weather bearings that allow us to do power generation in extremely, extremely cold weather. So it's really about the application and looking at, are there modifications we can make to our motor design or changing of the internals to meet a specific need, which allows us, Turntide's an extremely nimble company. So any of those type applications, definitely reach out and we'll do the research with you. So
Excellent. And here's a good one to end on, I think. As a key summary, what would you say summarize the advantages over say radio mo motors?
So I'll throw a little bit out there and then I'll let Nathan kind of close. But I think the biggest thing for me and what I work on a lot when it comes to hybridization of systems is space claim and torque density. Um, there's nothing better than an axial flux motor for space claim applications. It's really great because in between an envelope of 100 and say 100 millimeters and 110 millimeters, we can generate anywhere between 55 kilowatts and 240 kilowatts. So it's really about how much space we can take up and that torque density. Because our motors are so light, I mean, you can kind of see I've got one sitting right back here. Just an amazingly light motor, even fully, a 430 it's getting pretty heavy, but it's not so heavy that I can't pick it up. And it's really an awesome platform for existing powertrains or where space claim is really at a premium. I think they really shine there. Um, and then the other thing too is axial flux were kind of slow to get into the game, right? They were really complicated to manufacture. They were expensive to manufacture. And Turntide has taken that on in full force. And
Mhm.
we've really worked hard to commercialize our motors, bring that sale price down using new technology. We're constantly looking at innovating from materials that the housing's made out of to manufacturing process to bring the price of an axial flux down and really accelerating it. We're seeing it in the highest end automotive divisions now. Your Porsche, Ferrari, Lamborghini, they're all using axial flux. Your regular run-of-the-mill automotive is now using axial flux. So, you know, everybody's kind of pushing that direction, and Turntide is really pushing hard to bring the commercialized version of axial flux to the forefront of technology. We've got some really exciting programs coming up over the next 6 months or so that are really going to prove out all of the things that Turntide's pushing forward, from diesel hybridization to series drivetrains to axial flux in the most robust environments on the planet.
Absolutely. And yeah, I mean, to echo that, it really is the form factor. There is slight improvements in efficiency. I mean, but when you're talking, 92% efficient versus 95% efficient, that is an increase, but at the same time, those both likely meet the bill. And it's not to say that radial flux doesn't fit in certain applications. I mean, actually, Turntide does make a small radial flux motor as well, 7.2 kilowatts. So there's a when space claim or when you need a really tiny form factor and just a little bit of power, it's a great use case. We're definitely on both sides of that coin. But when we're talking large amounts of power, large amounts of torque, high speed, and being able to fit in large equipment, axial flux is close to none when it comes to that. And Turntide really has found our space in the sense that we're easy to integrate, low cost of manufacturing, which ultimately ends up to a lower cost of ownership for our end customers, and ease of integration from a bring up and controls perspective. So, a lot of really good questions we've got today. Wanted to remind everyone that if you visit our website, if you go under products, we do have documentation pertaining to all of our products, the data sheets, the product manuals, the integration guides, are all readily available there, as well as CAD. So you can start to put those into your design software and really start to see, okay, this is how this would fit in our system, in our use case, and then give Jason or myself a call, send us an email. We'd love to set up a meeting and talk more about it because this is a really great space that we're working in and it's really starting to explode.
Great. Well, thanks so much for the presentation, and thanks everyone for attending and submitting questions. That was a great conversation, lots of great technical depth. As I
Yeah.
mentioned earlier, the recording of the webinar will be available to view on demand, and you can use the same join link to watch the recording in about an hour when it's finished processing. And we'll also be sending out a follow-up email that will contain a link to the on-demand video, contact information where you can reach out to the guys here, and some links to some more resources. And of course, feel free to share all that with any colleagues who are not able to attend live today. So thanks again so much, Jason and Nathan. I really appreciate it. Great conversation.
Thank you very much.
Thank you for hosting us. Appreciate it.
Take care, guys.
Thanks, everyone.